Hi everyone, so we need to talk about what happens if you want to dilute a solution. Now the first thing to understand is when we talk about dilution, the meaning of diluting something refers to the act of, it might be called watering it down, as in to reduce the concentration by adding the solvent, which in this case we're going to focus on aqueous solution, so water. As far as like the main idea when it comes to dilutions, we need people to understand that dilutions change the concentration because of the addition of a solvent, and again, water is what we're focusing on this aqueous solutions unit. So the big take-home message is that the number of moles of solute will remain constant if you are adding solvent, i.e. water, to a solution. So when you dilute, the volume may change, but the number of moles of solute will remain constant. And there's a couple ways to handle that. Like if you want to calculate the concentration of a solution after it's been watered down, you can find out how many moles and divide by the new volume, and that's totally possible. But for a simplified approach, there's actually a nice equation that can be used, and that is this. Now, what is this all about? It has to do with the basic definition of how molarity works. So consider, why is this the case here? M stands for molarity, that's moles per liter. And then V stands for volume, that is liter. Now consider that if liter cancels liter, M times V is just moles. So if you take molarity times volume before you dilute something, and then molarity times volume after you dilute something, remember the number of moles of solute does not change, which means the number of moles of solute at the beginning is equal to the number of moles of solute at the end. And that means, therefore, that if you take molarity times volume at the beginning, whatever number it gets is the same as molarity times volume at the end, which is why we can set these directly equal to each other, and this becomes the equation that can be used to calculate how the volume changes, or I should say how the volume would need to change to make a new molarity, or how the molarity would change if you alter the volume. So, what is the actual application of this? Well, that's it essentially, and you're going to see a lot of verbiage of this kind when dealing with this sort of question. So the parameter to give on this is, first of all, if using this, it is necessary to memorize it because this will not be printed on the exam or given. So one has to remember molarity times volume equals molarity times volume. And we pronounce it as M1V1 equals M2V2. So how do you actually go about applying this? Let's look at how you use that for here. Let me see, do I have it on a separate thing? Yes, I do. What is this all about here? Let's talk about how you break down the equation to get this information out. If we're going to use this, we have to understand that molarity times volume, when it says number one, that means like at the beginning, and this would be like at the end. And I say it that way because I want you to understand, like, beginning means what you're starting with and what you end with. Now look at the wording of the equation. Suppose you want to prepare this, you understand it's a volume, right? This volume with this molarity. Think about the word prepare. Does it make sense? This is what you end up with. Okay, what we're gonna do is we're gonna label like which of these is where in the equation. So because when you prepare something, so you make in the end, I'm going to call this volume 2. Because that goes with this, this is molarity 2. Again, it's what you end up with. Now look at the wording here. So working with acetic acid, it's from a 17.5 molar stock solution. A stock solution, remember what the stock solution is? It's that solution of known concentration. Does it make sense that that's what you begin with? Now, this is a molarity, so we'll call this M1 because a stock solution will generally be what you start with. And then it says, what volume of the stock solution do you need? So if it goes with M1, it's V1. So what we're looking at here is identifying, looking at a question and pulling out, okay, how are we going to label each of the numbers and then put them into the equation. Now, when it comes to the equation, let's talk about the work I want you guys to show on the test, because of the fact that a correct answer without proper supporting work gets a 0. So how do you get work? If you're going to use an equation, it absolutely must be written, which means, yes, I know it's already written here, but for your work on the test, you will be rewriting the equation. You will then need to show your work for algebraically rearranging it conveniently done here, which means, okay, what are you doing? You're solving for this one. Okay, is it clear you gotta like divide both sides by the same number so that this cancels this, and therefore V1 equals that? I'll even erase this to show like, okay, that's what we've got, and that is this right here. So far so good. Once you've done that, you've shown your original equation and some sort of work for rearranging it, then you can plug the numbers in. Do not do this with numbers first. Remember, it's always units first, or in this case, it's the variables first. So that's what happened here. Here you see, like, plug in the numbers. Then you do your math. Okay, that times that divided by that, and your calculator spits out the answer. What is very nice about this is, like, think back to the previous questions. We've always been converting from milliliter to liter. That way it can work well with the liters that are inherent in this unit here. But because of the nature of this setup, look, molarity cancels molarity. You just have milliliters for your answers. So the nice thing is, it doesn't really matter what volume unit you start with. This could be liters, this could be gallons, this could be fluid ounces. It doesn't matter, because these all cancel. Whatever unit you put in will be the same you get out. So it is nice. It saves, means a little bit less in the way of work. Okay, so to recap, what do you need to get credit for this? You need to write the equation and some sort of work for rearranging it. Then you show the numbers plugged in, and then you box your final answer, properly rounded, because 3 sig figs, 3 sig figs, 3 sig figs, and 3 sig figs. All right, that's it.